Machine learning kind of feels like it just appeared out of nowhere, right? I mean, one minute, computers are basically just fancy calculators. The next, all of a sudden, they're creating incredible art, holding real conversations, even driving cars. But what if I told you that this overnight revolution is actually a 70-year-old story? Yeah, you heard that right. Let's get into it.
So, this is the big mystery we're going to try and solve today. If the basic ideas behind machine learning have been around since, like, the 1950s, why is it only now that it's completely changing everything? What on earth happened?
I mean, the difference between what we think is happening with machine learning and the actual history is just massive. It really feels like we're watching some sudden, brand new invention unfold. But the truth? We're actually seeing the payoff from a journey that's been going on for 7 whole decades. So, to really get what's happening today, we got to rewind. Let's go all the way back to the beginning.
All right, so let's travel back in time to the very dawn of the computer age. The big idea behind machine learning was actually super simple and, well, really human. The thought was, instead of programming a machine with, explicit step-by-step instructions for every single thing, what if we could just get it to learn from experience, just like we do?
And what's just wild is how fast the foundational pieces came together. I mean, look at this. In 43, we get a mathematical model of a brain cell, basically proving that thought could be turned into math. Then, in 1950, the legendary Alan Turing gives us a way to see if we're succeeding with his famous Turing test. And just a few years later, boom, 1957, we get the perceptron, which is basically a digital neuron. It was one of the first algorithms that could actually learn by trial and error. You could just feel it. The dream was starting to become real.
And the excitement back then, it was just off the charts. The pioneers in this field, they really, truly believed they were just a few decades away from creating human-level artificial intelligence. They thought they'd see it in their lifetimes, but they were wrong. And it's not because their ideas were bad. They were brilliant. The problem was the world just wasn't ready for them.
And that's when it hit. A long, cold period that researchers now call the AI winter. All that early hype and optimism, it just collapsed. The funding completely dried up, and the dream of a thinking machine, well, was put on ice for a very long time. The ideas were amazing, but they were just way, way ahead of their time.
This analogy just nails the problem perfectly. Think of the algorithms as this amazing athlete, full of raw potential, totally ready to go out there and win. But they were being starved. They were missing the two things they absolutely needed to get strong: food, which is the data they learn from, and oxygen, which is the computing power to actually process all that data. So let's be super clear about this. The food was data, and the oxygen was computing power. You see, for machine learning to work well, the models need to see millions, even billions of examples. But back in the 60s and 70s, there just wasn't that much digital data around to learn from, and the computers back then, so slow, so expensive, with tiny memories. Trying to train even a basic model was a huge, huge task. The athlete was literally starving.
But here's the thing. Progress didn't grind to a complete halt. During this AI winter, the research just got quieter, more focused. Instead of going for this grand vision of imitating a brain, scientists turned to good old-fashioned statistics. And that led to some really effective, but very narrow tools. Think about the early spam filters in your email. And then in '97, we got that huge moment when Deep Blue beat the world chess champion, Garry Kasparov. It proved that machines could be superior, but only in a very specific limited task. The big revolution was still on hold.
But, of course, that winter couldn't last forever. After decades of waiting, the world finally started to catch up. And what's so cool is that it wasn't just one thing that lit the fuse. No, it was a perfect storm. 3 massive tech shifts all hitting at pretty much the same time.
So, what finally changed? What were those key ingredients that finally fed our starved athlete and let machine learning explode into the powerhouse that we see today? What ended the long winter?
Here they are, the 3 pillars that hold up the entire modern ML revolution. First, the food finally arrived, and I mean an unimaginable explosion of data. Second, the oxygen showed up in the form of massive and, more importantly, accessible computing power. And third, we figured out how to scale up those old algorithms to actually use all this new food and oxygen. All right, let's break each one of these down.
Okay, first up, the food, the data. Think about it, the internet, smartphones, social media, All of a sudden, we, as a species, started creating more data in a single day than entire generations had produced in decades. Every photo, every post, every search, every click, it all became the fuel, the raw experience, that these machine learning models had been so desperate for.
Next, let's talk about the oxygen, the compute power. And this really puts it in perspective. Just imagine, something that used to take months of number crunching on a single multi-million-dollar supercomputer. Well, now it could be done in just a few hours by renting thousands of processors in the cloud. And the secret weapon here? The GPU, the graphics processing unit. Yep, the same chip that was designed to make your video games look amazing turned out to be the perfect engine for training these massive neural networks. A total game changer.
And this is the final and maybe the most important piece of the puzzle. A lot of today's big breakthroughs, like deep learning, are basically just scaled-up, massive versions of those original ideas from the 50s and 80s. The huge innovation wasn't some brand new theory. It was simply scale. It turns out, when you take those old algorithms and you give them a planet's worth of data and a supercomputer's worth of power, they suddenly start doing things that feel like actual magic.
So you take that data explosion, you add in massive compute, and you combine it with those scaled-up algorithms, and what do you get? Well, you get the revolution we're all living through right now. This is the payoff for that 70-year wait.
And you can pretty much pinpoint the turning point to around 2012. That's when these deep learning models, supercharged with all that data and all those GPUs, just started shattering records left and right. All of a sudden, speech recognition got so good it was nearly flawless. Computers actually became better than humans at recognizing what's in an image, and machine translation started to become genuinely useful. The dominoes just started to fall, and man, they fell fast.
Okay, if you remember just one thing from all of this, let it be this flight analogy. Think about it. We understood the physics of how flight works long before the Wright brothers ever took off. What we were missing were the right engines and the right materials to actually build a plane that could work on a massive scale. Machine learning is exactly the same story. The core theory was there for decades. It was just sitting there, waiting for the technology, the data, and the compute to finally catch up.
And now, today, that technology is, well, it's everywhere. This isn't some futuristic, abstract idea anymore. It's baked into the tools you and I use every single day. Ever wonder how your search engine just knows what you're looking for? Or how your favorite streaming service recommends the perfect movie for a Friday night? Yep, that's machine learning. It's the fraud alert you get from your bank. It's the filter on your video call. It's even the new creative tools that are writing text and generating art.
So, all of that brings us right here to today. This 70-year journey has hit an unbelievable turning point, but it leaves us with this huge, fascinating question for the future. Are these incredibly powerful systems just really, really good at recognizing patterns, just fed the data of our entire civilization? Or are we starting to see the first real sparks of something more, the very beginning of a true general intelligence? That is the question we are all now waiting to see answered.